Hello students. So welcome to construction technology and management. So before discussing about the critical path method, so first we have to identify what are the elements in the critical path method. So here a network diagram is there. It is a critical path method network. So in this network diagram, first of all, what are the elements in this? So a network is nothing but it shows a sequence and interdependence of the activities of a project in a diagrammatic form. Okay, so we have a set of activities. So this set of activities of any of the project, you have to represent them in a sequential order in a diagrammatic form using a standard symbols that represents that defines a network. Okay, a network is nothing but sequential arrangement of the activities by using a diagrammatic representation and standardized symbols. Okay, so that called as a network. Okay, sequential arrangement of the activities with the diagrammatic representation and standardized symbols. Okay, here there is an sample network is there. So A, B, C, D, E, F up to F is there. So the first activity starts with A and ends with F. Okay, so in between that we have represented with the arrow marks in between the each activity A to B, B to C, and sorry, A to B, B to D, D to F is there, right? So there are two basic elements in critical path method. That means in representation of a network diagram we have two basic elements are there. So one is activity and second one is event. Okay, so these are the two basic elements we have to know. One is activity and second one is event. So first, what is an activity actually? And sometimes there is another element also there, a dummy activity. So activity, event and dummy activity. What is a dummy activity actually? Activity is nothing but original activity, that means earthwork, foundation work, thereafter next structural work. These are the three main activities. So what is a dummy activity? So we have three different activities to follow. If these three activities are started at a simultaneously at a single time, if these in between these three activities, is there any logical relationship between the any two activities? That means we have started three activities at a time. So but we have to monitor them in these three activities. There is a relationship between two activities. That means these two activities have to complete at a time, then only the next activity will start it. So you have to monitor the completion of these two activities which are interrelated. That means which these two activities have a relationship, so that the next activity is started. So to identify the completion time, we will represent the logical relationship with a dummy activity. Okay, the dummy activity doesn't carry any time duration. It simply represents the logical relationship between the two main activities, so that the activities are completed on time or not. We have to monitor them. Then only the next activity started. So to monitor the logical relationship, that means to maintain the logical relationship, the dummy activity can be used. Okay, so first of all, what is an activity actually? So a project can broken down into various activities necessary for its completion. So the take a building project or take a bridge project, the entire project must be broken down into number of activities, right? So each activity will be represented by an arrow mark, okay, with the arrow symbol. And so the description of the activity is written above the arrow. That means what is the type of work, that whether it is excavation, whether it is concreting, whether it is surveying, or whether it is site investigation, or whatever it may be. So the description might represent on the top of the arrow, and what is the duration, 2 weeks, 3 weeks, 4 weeks. So you have to represent beneath the arrow with the number. Okay, so that is the representation of an activity. And the length of the arrow is not drawn to scale. That means there is no issues with the scale actually. So whatever the length you have to follow, you have to maintain some longer length. So there, as far as possible, the length of the arrow should be sufficiently long. Okay, and one more important thing, these arrows should not represent with the curved ones. Okay, the arrow should not be curved one. It should be straight, or it should bend in a straight direction only. So these are some sample representations over there to represent the arrow. So you should not represent that arrow with the curved one. Okay, so it should be straight. If it is bented, okay, it is okay, but it should not be in a curved manner, or it should not be in a reverse direction, always pointed towards the forward. Okay, it should not represent with the backward direction, but because the activity should not be reversed, right? Yeah, okay, so then the second element in the the network analysis, so event. So just now we have discussed about an activity. So what is an event actually? So event is nothing but it states the completion of the preceding activity and beginning of the new activity. So whenever an activity you are representing at the beginning and at the ending. So that means at the beginning of a new activity and at the ending of the corresponding activity. So you have to represent the activity in a specific symbol. That means in a circular manner. So that represent an active, that represent an event. Okay, so the event has no duration, no time duration. It is simply represented by a circle, and you can label with by a number. You can label the event with the number, so that it simply represents a milestone actually. That means number 1 is there, 2, 3, 4, 5. You have given 5 numbers actually. So 5 events are there. So in between the each event you have represented with the circular symbol. In between, inside the circle, you have given a number 1. So event 1 is there, and event 1, then after event 2, event 3, and event 4, event 5 are there. So that you can monitor the entire project is going in a right way or not by using these following events. How many events are completed? Okay, so there is a diagrammatic representation over there. I and J are the events here, and in between the event 1 and event 2 there is an activity, okay, represented with the arrow mark. So here one event is there, so this is our benchmark 1. So and this is J is the second event. So in order to move from the event 1 to event 2, a activity have to done. So that activity we have represented with the arrow mark here. That means here we have to that means site investigation. Assume the I is a site investigation, and the next one, the J is a event which is called as concreting work, right? In between these two, if we have to go for the next activities in between these two, what we have to do? Earthwork excavation we have to do. That means that is the activity here. Okay, so what is the event and what is the activity? Okay, and so then what about the dummy activity actually? So just now we have said dummy activity can be represented by the dotted arrow. So it should not represent any main activity. So it will not represent any main activity. The dummy activity just gives you the information of logical relationship between the different activities. So just now we have discussed. So there is a logical relationship, that means there is an interlinking between the two activities. If the two activities are completed simultaneously, then only the next activity is started. Okay, in that particular manner, in that particular way, so you have to monitor that two activities simultaneously. So you have to represent with the arrow mark in between the two activities. So if any superimposed activity is there, okay, for a specific operation or process, and it has zero duration and it consumes no resources. So for the dummy activities, you don't need any resources, and you don't need any duration. It is simply to identify the logical relationship. That means it is simply to observe the activities whether they are completed or not. Okay, just to identify the activities are completed or not. So that doesn't take any resources there. Okay, like normal activities, dummy activities will not consume any resources, but for normal activities you need equipment, you need manpower, all these things, that because they are main activities. But for dummy activities, that means for identifying the relationship, or the identifying the whether the activity is completed or not, so that for that purpose, you don't need any resources, right? And so here you can see on the third point, it provides a logical link. Okay, the main purpose is to provide a logical link to maintain the correct relationship between the activities. Okay, and to simplify the description of concurrent activities. Concurrent activities means the activities which are planned simultaneously, side by side. That means the mm, site investigation is going on. After site investigation, earthwork excavation is going on, and as along with the earthwork excavation, approach road is also constructed. So after by then the reinforcement bar bending also simultaneously going on. So earthwork excavation is going on, bar bending is going on. If these two completed, then only you can construct the foundation over there. So you have to complete these two activities simultaneously. Then only you can pour the concrete at the foundation, right? So the foundation work is the corresponding third activity. But activity 1 and 2 are the excavation process and bar bending. So then only you can put the foundation over there. So in between the activities, the earthwork and the bar bending, there is a interlinking, there is a relationship between these two activities. So you have to monitor these two activities simultaneously with a dummy activity. Okay. So in chart, you have to represent the arrow mark between the two activities with the dotted symbols. Okay. So I will show you one diagram over there. So you will get the idea about this. So here you can see a diagrammatic representation is there, a network chart is there. So here the activity D, okay, the activity D, it consumes 1 day. Assume it consumes 1 day. So after the activity D, what is the next activity? E is the activity which is following. Okay, it consumes 3 days. So 4 is the event. Okay, so event number 4. So we have attained the event here. So and here simultaneously the activity at the bottom, the activity C is happening. It consumes 2 days. So here C and D are the concurrent activities. That means these two are planned simultaneously. So it takes 1 day and it takes 2 days. So here after the C, the activity is F is the following activity after C. Okay. So if the C and D are completed only simultaneously, then only the next activity E will be started. Here the point is, after the completion of C, here you can see the dotted arrow showing from C to, that means from 3 to 4 here. Okay, arrow mark started at 3 and it pointed out to the 4. That means a logical relationship is there between C and D. That means if C and D are completed only, after the completion of these two activities only, the next activity E will be started. That's why we have represented in between the C and D with a dotted arrow pointed out towards the event 4. Okay, right? So C and D are completed, then you can start E. Okay, then the E activity you can start. But before without completing these two activities, you cannot start E. But you can start F after the completion of C. Okay, that is the thing. Okay, you can start the activity F because there is no interrelationship between the activity F, the starting of activity F. There is no problem with the completion of D only. Okay, here the activity D will not show any effect on the activity F, but here the activities C and D will affect the activity E. Okay, that is the thing. So there is a relationship between the C and D for starting the next activity E. Okay, that's why. So to start this, to show this in a diagrammatic representation between C and D, a arrow mark, a dotted arrow mark is there. This dotted arrow mark is called as dummy activity, which is represented with H. The dummy activity is just only to identify the completion time. If that two C and D activities are what is the status of the two activities, if they are completed or not, that purpose only we will put the dummy activity between these two. So we can achieve the event 5 over there. So if we monitor all these 4 activities along with the dummy activities successfully, here 1 day is there, 3 days are there, bottom line 2 days are there. So totally it takes 8 days to complete this entire chart. So you can monitor the machines and you can monitor the workers. So 3 days over there, only 2 days over there, you have to complete the project on time. You can give instructions to them. So by analyzing this chart, you will get the idea about the what are the next activities we have maintained, and how many days time are there for completion. So you have to motivate your workers and you have to move up the activities on time. Okay, so this is the representation of a activities in a diagrammatic representation. So just now, that means we have learned about what are the elements and what is the representation of them. Just we have learned about the elements, what are the elements in this and what is the representation of them. So you can see here the normal arrow is there, which is represented with the description on the top and time duration at the bottom, and the circular one is there, inside a number is there, so it represents an event, and inside the event number is there. Okay, and after in between the activities, if there is a relationship, so we have to give a dotted arrow mark which is represented with a description, so it called as a dummy activity. So these are the three elements: activity, event and dummy activity. So these are the three main elements in the CPM network. Okay, so this is about the elements in critical path method network analysis. So in next class we will discuss about what are the steps needed in the critical path method.